Welcome to the quadratic graph stretching. So we're going to look at vertical stretching, vertical compression, and reflection in the x-axis today. So again, it's kind of like an investigation, so feel free to kind of go through it on your own and then kind of double check the video. So we're going to start here with the parent graph, the base graph. Let's practice filling in the table values here. We're going to graph it, and then we're going to analyze where the vertex and the axis of symmetry is. So hopefully from the last lesson you can fill this part in pretty quick, but we're just going to analyze this base graph here. So let's start filling in the table values here. So we have this equation y equals x squared. So we're going to use that to calculate the y values in this table values here. So the first value of x is -3. So we're going to plug it into this equation. So whenever we plug it in, so I'll do the work here. We always put brackets around the value that we plug in. Okay, and then squared. So from there, BEDMAS will say, look in the brackets, nothing to do. Next thing is do the exponents. So this is the same as taking -3 and multiplying it with another -3. So you end up with +9. Okay, and that's what you'll place into the table values here. Okay, do the same thing with -2. So again, we're going to plug it in. Okay, so it's the same as -2 times -2 is +4. Okay, and plug it in. So from there, hopefully you can calculate the rest in your head. -1 times -1, 0 times 0, 1 times 1, 2 times 2, 3 times 3. So then graph the table values now. So this is your x and your y value. So graph them on the graph here. So I'll use different color dots here. Maybe I'll use red. No, I'll use, I don't know, blue, no, green. Okay, so the first dot that we have to plot is -3, +9. So again, this is your x and y axis here. Okay, so always plot the x first. So it's -3, 1, 2, 3, and then it's +9, 3, 6, 9. Okay, and then -2 and 4. Okay, -1 and 1. 0, 0, 1, 1. Hopefully you can see where the other one goes because it's supposed to be symmetric. Grab those a little quicker. All right, and the usual nice smooth curve. Bottom should be a U shape here. Okay, and then the rest. Get through those points here. If you're a little bit wobbly. Okay, arrowheads at the end. Okay, and always use the whole graph grid that you have. Whoops, missed. Okay, and then label your equation. Okay, so from there, you need to fill in the vertex and the axis of symmetry. So again, even if I say axis of symmetry, I mean the equation, so always write that. So you can see that it's at 0, 0 with the vertex. There it is right here. And then the axis symmetry, right, is x equals 0. Okay, it goes right to the center there. And again, you always look at the x value of the vertex. That was us just taking another look at the parent or base graph. So the main points here, like you'll graph this so many times that you'll have these memorized. So again, vertex is always at 0, 0. There's always that 1, 1, 2, 4, 3, 9. Okay. So we're going to start analyzing something else called a step pattern here. And so just scroll down here. Okay, so here's the same graph as the one up there. So I want to look at the step pattern on a nice graph, not a wobbly one like the one I drew up here. So I want you to start at the vertex, and then it says here to go left or right from the vertex. So we'll go right first. So starting at the vertex, the step pattern is, so turn it to red here. Okay, so starting at the vertex, vertex is right here. You're going to go over 1, and then you're going to go up to the next nice point here, and there it is. Okay. All right, so then the next step pattern is you always go over 1, and then you go up until you hit the graph. There it is. Okay, over 1, go until you hit the graph. It's right there. Okay, so I'll change those to different colors here. Okay, so this one's there. Okay, so what did we notice? So whenever we went over 1, we went up 1. Okay, then from that point, if we go over 1, okay, so over 1, up 1, over 1, up 3. Okay, the next one, over 1, up 5. Okay, so the step pattern here is 1, 3, 5. Okay, so I just want to introduce that to you today. We're gonna look at it a bit more in in a future lesson so that you can graph these really quickly. So for now, that's the main thing here. If you wanted to graph those important points on the base function, so you always start at 0, 0, and then it goes 1, 1, but all you have to do is go over 1, up 1, over 1, up 3, over 1, up 5, and then you can find those points really quick. And then on the other side, because it's symmetric, it's easy to plot the other ones really quick because it should be right across. So here's this one, straight across, and straight across here. Okay, and then you get a nice graph. Okay, so when you have the vertex and a couple points on, so we have 3 points on each side of the vertex, but if you have a vertex and a couple points, those are good points to graph on the parabola. Okay, so 5 standard points. So if I in the future ask you to graph a parabola with 5 nice points, that's what I always want to see. I want to see one, the point that's the vertex, and then a couple nice ones on the other side of the vertex, and then the left side of the vertex here. Okay, so moving on now to the main part of our lesson. So we're looking at what happens to the equation when we stretch, compress, reflect. Okay, so we'll look at vertical stretches first. So what we're going to look at here is y equals x squared, but now there's this a value in front. So we're analyzing this number that's changing in front of the x squared. So we're going to analyze all the a values that are greater than 1. Okay, so here, like 2 and 3. So what will happen to the graph when we now multiply these values in front? So I want you to do that investigation. You're going to go through here, calculate them using the equation here, fill them in, and then I want you to graph them on here. So I went ahead and calculated all of the values. So again, if you just take -2 and square it, you get 4. Over here, if you take -2, remember BEDMAS says exponents first, so square it first, 4, then you do multiplication, times 2 is 8. Okay, so -2 squared is 4, times 3 is 12. So that's how I calculated these. So I started graphing here. So I put the original parent function in. So again, 0, 0, 1, 1, 2, 4. Okay, tried to make a smooth curve. I labeled it, and then I went to the next one and graphed the y equals 2x squared. And so what you'll notice here is the vertex is still in the same spot, but then what are you noticing with, it used to be 1, 1, and now it's 1, 2, okay? So So if you're analyzing it, you're noticing that it actually doubled. Okay, so it used to be 4, it doubled to 8. 4 doubled to 8 here, okay? So it's being stretched. So basically here was the original, but now you're stretching it up vertically. So we'll graph the next one here. Okay, so we have still the same vertex, but now we're going up to 3. So it's like tripled. Okay, -3, and then up to 12 here. Okay, so my graphs are a little bit wobbly, so they're going to hit, but it should be so that it's going through the vertex. Okay, so we have the 3 graphs on the same grid here. So again, the red one here is the parent graph, the original graph. The next one, we multiplied the equation by 2, and then you're taking a look at the blue here. So you're finding that it's inside the red. And then the green one here, it's multiplied by 3 is inside. Okay, so the reason why we call this a stretch is because, so you start off with the red one, and then you're going to start stretching, by 2, doubling it, okay? So the arms are going up higher. So as you increase the factor a, the number that's in front of the x squared, you will find that there's a greater and greater stretch involved. A little figurine here drawn. So think of it as when you are applying a vertical stretch. So your arms are already going up in the air. So if we're doubling now the expression, your arms will be pulled up straighter into the air. So for example, now if I pull with more power, the arms will go here. Okay, and then if I triple the power, again, the arms will go straighter up in the air. So here is a summary. So if you have the graph y equals x squared, and you apply a value here, so the value is greater than 1, so like 2, 3, 4, you're going to find that the graph will now have a vertical stretch by a factor of the a value here. So if you want to take a look here at the y equals 2x squared, so compared to the original graph, y equals x squared here, we're going to compare and describe what happened now with y equals 2x squared. So put it over here. So y equals 2x squared. The way you would describe this transformation is that there has been a vertical stretch by a factor of 2. Okay, so again, if you're analyzing from the red to the blue here, you'll find that it used to go up to 1, but now it's going up twice as fast. Okay, so it used to go up to 1, 1 and 1, now it's 1 and 2. And if you multiply by 3, 1 and 3. All right, so if you go to y equals 3x squared, that one will be described as a vertical stretch by a factor of 3. Okay, so one last point here. If you analyze the table of values up here at the top, so for y equals x squared, these are the typical 5 points. What did you notice when we went and multiplied it by 2 here? You found that the x's didn't change, but the y's all got doubled. And then again, back to the original, what did you notice when it was multiplied by 3? All the y's got tripled. So it's just a little note here. So if you were to graph it, all you have to do is take all the y values of x squared and multiply it by the a value, okay, to find the y value. So whatever value ends up sitting here, you can multiply all the y values to get the new y values really quickly. All right, so we'll move on to our vertical compression investigation now. So if you take a look here, we're going to analyze the new a value here. Again, as it's in front, it's going to be a value between 0 and 1. So what we're looking at are fractions, okay, 1/2, 1/4, and so forth, but it has to be between 0 and 1. Okay, so again, I'm going to go through and fill in these values. So again, all you're going to do is take your -2, square it first, and then multiply it by 1/2, or think of it as like dividing by 2. Okay, so go through, fill this in, and then work ahead and graph all the 3 of these functions so we can analyze it. So we worked ahead and calculated out the y values here. Okay, so and then we graph them. So the red, that's the parent function. So here it is, same typical points. Okay, but what happens now when we multiply by 1/2? Okay, so we're finding that the blue is over here now. Okay, it's on the outside. So before, when it was a stretch, it was on the inside, but now what we're finding is that it's out here. Okay, and if it's multiplied by 1/4, it's further out. So what's happening here is a vertical compression. So think of it just like our little analogy of this guy here. His arms are being pulled up. So if you're going to pull with double the power, your arms are going to go up higher. So again, here is the parent. So if you are now not pulling up with as much power, arm's going to droop a bit. Okay, even less power, arm's going to droop a bit. Okay, so again, if you want to draw the analogy, so we have our guy here, little person here with their arms. Okay, so the arms are already going up like this. So that's the y equals x squared. But now we're going to only pull the arms up by using 1/2 the power. So you're going to find that the arms are going to droop a bit. Okay, so that's why they call this a vertical compression. So it's like the arms are going down and they're going lower. Okay, so if we look at the summary here, so again, we're analyzing this a value. It's important. So when it was greater than 1, we found that the stretching was greater. Okay, the arms are going up higher. But now, if the value is between 0 and 1, so it's a fraction like 1/2, 1/4, between 0 and 1, you're going to find that there is a compression, okay, by a factor of 1/a. Okay, so let's just write down what that looks like here. I'll write one here, write one there. So for the y equals 1/2 x squared, to describe this compared to the red one, the original graph, there was a vertical compression by a factor of 2. So if you see if you see that the a value, okay, so if we do the work down here, so if you see that the a value is 1/2, we have to say that the vertical compression is, so this is the shorthand, vertical compression of 1/a. That's what we have to state. So if we take our a and put it in here, okay, so again, like when you have a fraction, you have to divide a fraction, you have to flip it. So you end up with 2/1 like that. So you end up with 2. Okay, so you would say a vertical compression by a factor of 2. All right, so we'll do the other one here on the side. So if we have y equals 1/4 times x squared, okay, so what's going to happen here compared to the original red graph? You're going to get a vertical compression okay, by a factor of 4. Okay, so a lot of my students in the past say, okay, so you just look at the bottom number of the fraction and put the value here. Yeah, so that's how you can think of it as well. Okay. Okay, so here's the summary. So we looked at, these are the terms that use vertical compression, vertically compressed by a factor of 1 over a. So again, just take the bottom of the fraction and just say 2 or 4. What you'll notice in the table of values here is something similar to what we saw with the stretch. So if we multiplied by 2, the y multiplied by 2. Multiplied by 3, the y multiplied by 3. With the compressions, if we take our original function multiplied by 1/2, all of the y values will multiply by 1/2, or you can think of it as dividing by 2. Okay, so you can think of this, yeah, so dividing by 2. And this one here, you multiply by 1/4, so all the y values from here to here end up multiplying by 1/4, or think of it as dividing by 4. Okay, so now we'll move on to the reflections. Okay, so what we're looking at here now is that the a value is negative. So we're looking at the sign here. So if it's positive, we're looking at something. If it's negative, we're looking at something else. So again, go ahead, work through here, calculate these out. So again, respect the negative, take the square first, then multiply by the negative. Take the square here first, and then multiply by -2, and then calculate your values out, and then graph it. Okay, so we filled in the table of values now for the new equations here. So here's our parent again. Here are our typical 5 points. Now, what happens if we put a negative? So again, we're going to take the -2, put it in here, square it, makes it +4, but then this negative still outside, so you get -4. Okay, and same thing here, square it first, then multiply by -2, so then you get -8, -2, etc. So we went ahead and graphed it here. So there's the parent. And then we'll look at the blue here first. So what happens if we just put a negative in front? Okay, so we're finding that it took the red here and flipped it down. Okay, so reflected in the x-axis. Okay, so it's like there's a mirror here. So the points like 1, 1 is right there. So now it's just 1, -1. -1, 1 became -1, -1. Okay, this point here is reflected over here. This point here is reflected there. Okay, and then this -2 here. So the negative will flip it down, but then the 2, remember from before, is a vertical stretch. So you found that, see how it's inside the blue here? Okay, so you have a reflection in the x-axis and a vertical stretch. So our summary here is, again, we're analyzing always what's in front of the x squared here. If it is less than 0, so if it's negative, then the graph will be reflected in the x-axis. If we're looking at the table values here, so again, as soon as you change something here, it changes the y value. So here are the y values. What happened here is we simply multiply by negative, so all the y values change to negative. Okay, so again, 0 doesn't take a sign on it. And then here, again, here's the original. We multiply this by -2, so 4 times 2, 1 times -2 makes these values here. Okay, so we'll quickly just describe what happened with each of these graphs here. So we'll start off with y equals -x squared. So compared to the original red y equals x squared graph, we had a reflection in the x-axis. Okay, so it's important that you guys say x-axis because next year you'll learn about reflection in the y-axis. Also, with the previous ones above, we had to say vertical stretch, vertical compression, because there will be a horizontal stretch, horizontal compression next year that you have to study. So just make sure use the proper terminology when you're asked to describe the transformation. Okay, so again, back to comparing to the original parent graph, y equals x squared. How did the y equals -2x squared change? Okay, y equals negative 2x squared. So we had a couple things happen here. So we have this negative, and we also have this 2. So there's a couple things here. So for the negative, we could say it's a reflection. Okay, so we can even call this A and B. So A, there was a reflection in the x-axis. And B, this 2 here. Remember, if it's a number greater than 1, it's a vertical stretch. So think of it as those arms stretching up by a power of 2, okay, factor of 2. So vertical stretch by a factor of 2. So again, make sure that you go through and write the whole word out and use proper terminology by a factor of 2 to get full marks. All right, so that ends our investigation. So we can make a grand summary here, summary of all the summaries. Okay, so again, we were studying the a value here. So if we were to just write this in here, y equals ax squared. Okay, so we were studying now what happened when this value of a changed, it starts off as 1 for the parent. What happens when we put some other value in there? So if we put a value of greater than 0, so positive value, you're going to get a factor, a vertical stretch by a factor of a. Okay, so here's an example, y equals 2x squared, vertical stretch by factor of 2. All right, and if you have a value between 0 and 1, so like 1/2, 1/4, 3/4, you're going to have a vertical compression by a factor of 1 over a. So again, what you do instead is just, when it's a 1 over fraction, just take the value at the bottom, okay? So it's like you just flip the fraction. Vertical compression by a factor of 2, that's what you write here, okay? Don't write of 1/2. So it's almost like, 'cause if you did that, it's like you're telling us you had a compression, and then you're saying 1/2, so you're saying divide it by 2, so it's almost taking it and doubling, I guess, the compression, which is not what we want. So just go vertical compression by a factor of 2. And then the last one here, a is less than 0. So if you have a negative value, if you just see a negative there, then you know it's a reflection. Okay, so remember the actual value of a determines the stretch or compression, but if you know there's a negative there, you could just say reflection in the x-axis. Okay, so go ahead and try these couple examples here. And again, remember you can always use Desmos to double check your work. And then here are some textbook questions that you can work through. I made a little sheet where I can cut out parts of the textbook so that you can actually draw on here, because we don't want you drawing in the textbook. Okay, so yeah, so once you're done, you can double check the filled notes online, and then you can see if you did it correctly or use Desmos. Okay, all right, so just make sure do all the work, and this checkpoint, there should be a checkpoint attached, so finish that up as well and submit it. Okay, thanks.